Imagine you are a privileged observer of the cosmos. You're accustomed to watching celestial bodies move according to the laws we've struggled so hard to decipher: elliptical orbits, gravitational principles, patterns of comet tail formation. Yet one day, an object emerges that defies every one of these rules. It approaches our sun from an unknown origin, accelerates and decelerates without apparent cause, changes color as if alive, and emits gases that shouldn't be there. This is the feeling I get whenever I think of 3I Atlas, an interstellar visitor that forces us to reconsider everything we thought we knew. Since its discovery, I've devoted myself to studying this object with a fascination tinged with unease. In this narrative, I want to share with you the story of the new anomaly we identified during its perihelion, that phase of its orbit when it came closest to the sun and revealed behavior so unexpected it left the scientific community in a state of shock. It all began on July 1, 2025, when the Atlas Asteroid Warning System detected a glowing point moving at an unusual speed. We quickly realized that this object's orbit wasn't closed, like that of a typical comet, but hyperbolic, meaning it came from beyond our solar system and would not return. It was the third interstellar object recorded by humanity, following Oumuamua and Borisov. We named it 3I Atlas. Unlike Oumuamua, detected as it was already departing, this time we had several months to prepare our instruments, calculate its trajectory, and plan observations. From the outset, 3I Atlas proved different. Its speed exceeded 130,000 kilometers per hour, making it the fastest object ever observed in the solar vicinity. Its size, though hard to pinpoint precisely, seemed to span several kilometers, perhaps 3 or 5, maybe more. Soon, we noticed its nucleus was releasing jets of gas at great distances from the sun, indicating the presence of highly volatile compounds. The initial data already hinted at peculiarities. Analyzing its trajectory, we found it was almost perfectly aligned with the ecliptic plane, that imaginary band marking the path of the planets. Most objects arriving from other systems appear above or below this plane. But 3I Atlas followed the same cosmic highway as Venus, Earth, and Mars. Moreover, its route took it relatively close to these three worlds before heading toward Jupiter. It was as if a probe had been designed to scout the solar system. The odds of an interstellar visitor aligning so precisely were vanishingly small. It wasn't impossible, but it was astonishing. Then came the first observable anomaly, a tail or jet directed toward the sun. Typically, a comet's tail extends away from the sun, as solar wind pushes dust and gas outward. Yet, on images of 3I Atlas, we saw a stream of gas and particles seemingly pointed at the sun. Some suggested it was a visual effect. Others, like myself, thought it might be a jet of carbon dioxide and carbon monoxide emitted from a depression in the nucleus, a possible but exceedingly rare process for known comets. As we gathered more spectra, the composition of 3I Atlas stunned us. Its coma was rich in carbon dioxide and cyanide, while water, dominant in solar system comets, made up only 4% of total emissions. Even stranger was the detection of nickel vapors and nickel tetracarbonyl, a compound used in industrial processes on Earth. Normally, metallic vapors contain iron and nickel in similar proportions, but in 3I Atlas, we found significantly more nickel than iron. Some colleagues jokingly suggested the comet was a roving steel mill. In earnest, the predominance of nickel without its usual companion was baffling and fueled speculation. The estimated mass, calculated from the apparent non-gravitational acceleration, also proved colossal. For a comet to resist deviation despite powerful jet emissions, it had to have a mass of tens of billions of tons, a figure larger than any known comet. This immense mass, combined with its odd composition, was hard to reconcile with models of interstellar object formation. Nevertheless, we strove to remain composed. Science thrives on anomalies, as they provide opportunities for learning. The National Aeronautics and Space Administration, the European Space Agency, and numerous observatories organized a global observation plan. While the American agency publicly reiterated there was no cause for alarm, with a minimum distance to Earth exceeding 260 million kilometers, it internally activated planetary defense protocols as a precaution. Telescopes were coordinated, observations with probes were scheduled, and even rapid intercept missions were proposed. We were ready for any eventuality. Yet, despite our preparations, nothing could have prepared us for what happened when 3I Atlas reached perihelion, its closest approach to the sun, in late October 2025. In the days leading up to perihelion, several solar probes, such as Stereo A, SOHO, and GOES, designed to observe the solar corona and solar wind, began recording unexpected behavior. Since the comet was behind the Sun from Earth's perspective, our telescopes couldn't see it. Only these space probes had the right vantage point. They first noticed that 3I Atlas's brightness was increasing far more rapidly than expected for a typical comet. Its brightness curve followed an inverse relationship with the distance to the Sun raised to the power of -7.5, meaning its brightness multiplied several times with each slight decrease in distance. This was faster than any comet previously observed. But the most astonishing event occurred on October 29, when Stereo A and SOHO instruments captured that the comet had become bluer than the Sun. Yes, a comet bluer than our star. To any astronomer, this is near blasphemy. The Sun's light comprises all colors, and its surface temperature of nearly 6,000 degrees gives it a white-yellowish hue. Comets, made of dust and ice, typically reflect sunlight in ways that favor reddish or yellowish tones. Dust scattering also colors the coma. Yet 3I Atlas exhibited an intense blue glow. Data showed the blue light came from emissions of ionized gases in the coma, not reflected dust. This bluish hue became a new anomaly, the 9th or 10th depending on who's counting, adding to the list of unexpected behaviors. For scientists, the first question was, what gas emits blue light in a comet? Preliminary analysis pointed to carbon monoxide and carbon dioxide excited by solar radiation. These gases can emit in the blue spectrum when electrons transition between energy levels. But why now? Why not throughout its journey? One possible answer is that the heat of perihelion fractured the comet's nucleus, exposing new material deposits and triggering gas outbursts that hadn't appeared before. Another possibility is that the sun-directed jet was merely the tip of an iceberg of activity unleashed at the moment of closest solar approach. There's also a theory that this blue light stemmed from a type of plasma rarely formed on comet surfaces. And of course, there are always enthusiasts who don't rule out the light being artificial, produced by an engine or controlled reaction. There's no evidence for this, but the imagination runs wild when faced with the unknown. The speed of the change and the intensity of the color left us stunned. Multiple missions recorded a halo of material extending over 300,000 kilometers around the comet. It was as if a colossal cloud of gas and dust enveloped the nucleus. It resembled the carbon dioxide jets observed by the Sphere-X observatory months earlier, but amplified on a massive scale. Some colleagues calculated that the gas released during those days equated to the loss of a significant portion of the comet's mass. This would explain the observed non-gravitational acceleration. With such intense gas ejection, the mass decreased, and the nucleus was pushed in the opposite direction. However, this hypothesis has a problem. A giant plume emanating from the nucleus should be visible, even in low-resolution images. So far, images showed a diffuse glow, not a concentrated jet. It might be a distributed process, as if the entire surface were releasing gas simultaneously. The National Aeronautics and Space Administration and the European Space Agency, in an unusual move, issued a joint statement noting that perihelion observations revealed an unexpected brightness increase and color change in 3I Atlas. They clarified it posed no threat to Earth, but the scientific community was diligently studying the mechanisms behind this phenomenon. The message didn't fully quell speculation. On social media and scientific forums, conspiracy theories multiplied. Some claimed the comet had activated an engine, others that it was a dimensional portal, others still, that the American agency was hiding its fragmentation into pieces. The truth, as usual, was less sensational but equally captivating. We have data, yes, but not all the puzzle pieces. The blue hue might indicate chemical processes we hadn't previously considered. The glowing halo could reveal the comet's inner layers, protected for billions of years and now visible as outer material sublimates. The acceleration might be a natural effect amplified by an unusual composition. Science, with its pace and rigor, demands patience before we draw conclusions. These past months, I've spent hours analyzing data from solar missions. I've studied brightness curves, false color images, emission spectra of each gas. I've consulted with colleagues specializing in spectroscopy, orbital dynamics, and plasma physics. Each contributes a piece to the puzzle. For instance, some comet dynamics experts suggest the blue color could result from the recombination of carbon monoxide ions occurring at specific temperatures and pressures. Others believe it might indicate the presence of complex molecules that typically don't survive in interstellar space, but could have remained frozen here until now. There's also discussion of the possibility that the comet passed through a dust and gas cloud during its journey, collecting material now being spectacularly released. These are all hypotheses. The only certainty is that this phenomenon doesn't align with what we've seen in solar system comets. To grasp the significance of this ninth anomaly, it's helpful to briefly review the 8 prior ones documented before perihelion. The first, as I mentioned, is the alignment of its trajectory with the ecliptic plane, statistically highly improbable. The second is the sun-directed jet, a behavior almost never seen. The third is the enormous mass inferred from its parameters and resistance to deviation. The fourth is the coincidence of its passage near Venus, Earth, and Mars, plus its upcoming encounter with Jupiter. The fifth is the composition of its coma, rich in nickel and carbon dioxide, with minimal water content. The sixth is the extreme negative polarization of reflected light, unprecedented. The seventh is the coincidence of its arrival direction with the sky region of the famous WOW signal, a radio burst detected in 1977. The eighth is the non-gravitational acceleration measured around perihelion, with a velocity increase of tens of kilometers per day squared, not easily attributable to gas ejection. Now we add a ninth. The blue coloration and brightness surge at a pace surpassing any known comet. Each of these peculiarities, taken alone, could be explained by a rare natural phenomenon. But together, they paint a picture so improbable that many wonder if we're dealing with something more than a comet. Among proponents of the artificial hypothesis, a notable astrophysicist calculated the odds of all these anomalies occurring naturally and found them vanishingly small. He suggests 3I Atlas could be a spacecraft, an interstellar probe, or an artifact built by an advanced civilization. According to this theory, the blue hue might result from the activation of a plasma engine powered by gases like carbon dioxide and carbon monoxide. The observed acceleration could be a deliberate thrust. The alignment with the ecliptic and visits to multiple planets, an observation plan. And the excess nickel without iron, an engineering signature. His arguments are bold and, I admit, invigorating. Yet, I can't forget that science demands robust evidence. It's not enough for something to be improbable to claim it's artificial. Exotic scenarios in nature aren't impossible, they're why we keep studying the universe. From a naturalistic perspective, one explanation we're exploring for the blue hue and extreme brightness is structural fracturing of the nucleus. We know comets are made of ice, dust, and rocks held together. In this case, the sun's heat could have cracked 3I Atlas's crust, releasing gas pockets sealed since its formation. These controlled explosions could generate gas emissions in all directions. If the gas contains ionizable molecules like carbon monoxide, the emitted light could be blue. Additionally, releasing large gas quantities would cause the observed acceleration. Another hypothesis suggests the comet is coated with a layer of organic compounds that burn when exposed to the sun, creating a bluish flame. We don't know what the chemistry of a body formed around another star looks like. Perhaps its ice isn't water, but something more complex. I mentioned that the National Aeronautics and Space Administration was cautious in its communications. During perihelion, some of its websites temporarily stopped updating, which many interpreted as an attempt to conceal information. The official explanation was that the United States government was undergoing an administrative shutdown, and the staff responsible for those pages were unavailable. It may sound like an excuse, but the reality is that government shutdowns affect many operations. Meanwhile, the scientific community pressed on. The International Asteroid Warning Network, led by the American agency in collaboration with other institutions, coordinated observations with telescopes worldwide. It was even suggested that a European team might launch a probe to fly by the comet, though time is limited. Perihelion data are being meticulously analyzed. If the blue hue persists in the coming months, it could mean the surface has permanently changed or that the comet is releasing material in shadow. The days after perihelion were intense. As the comet emerged from the solar shadow and became visible from Earth again, telescope networks prepared to monitor it. We hope to measure the nucleus's size, confirm the amount of mass lost, and determine if the acceleration persists. The European Space Agency's JUICE mission, en route to Jupiter, plans to aim its instruments at the comet in November when its trajectory brings it closer to the spacecraft. The Juno orbiter, studying Jupiter, may provide microwave data revealing the comet's internal temperature and the presence of cavities. These observations will be critical to understanding the blue glow anomaly and the acceleration. Meanwhile, scientists from the Parker Solar Probe mission, which ventured into the solar corona, used its proximity to the comet to measure the solar wind's impact on its environment. The probe detected magnetic field variations coinciding with the comet's gas emissions, suggesting the object strongly interacts with the solar environment. If confirmed, this would explain the extreme light polarization and blue color. A locally distorted magnetic field could accelerate electrons and generate blue emission. The debate over 3I Atlas's origin will continue. Perhaps in a few months, when the comet passes closer to Earth in December and the Hubble and James Webb telescopes observe it, we'll learn whether its surface reflects blue light or emits it only near the Sun. The James Webb, with its infrared spectrometer, might detect complex organic molecules. Hubble, with its high-resolution camera, could discern fragments or jets. There's already speculation that the comet might release small spheres or mini-probes, a hypothesis born from some researchers' imaginations. So far, there's no evidence of such spheres, but if small lights appeared around the comet, it would be hard to deny artificiality. Speaking of signals, I can't ignore the controversy over alleged messages on the hydrogen frequency and Fibonacci sequence that circulated online. There's no evidence the comet emitted numerical pulses. In fact, the scientific community debunked this news as rumor. But the excitement it sparked shows our yearning to find messages in the dark. The Fibonacci sequence is universal, appearing in nature and mathematics. Some suggest an advanced civilization would use it for communication. The reality is that no artificial signals have been detected so far. The true signal 3I Atlas sends us is its very existence, a reminder that the universe is full of surprises, that our understanding is limited, and that even a comet can behave in ways that take our breath away. Personally, this blue glow anomaly during perihelion has led me to reassess my beliefs. Throughout my career, I've seen seemingly solid theories collapse in the face of unexpected observations. When Oumuamua passed by, many thought it was an elongated asteroid or comet fragment. Today, we know its shape and acceleration remain unexplained. Now comes 3I Atlas, raising the stakes. It's larger, faster, more massive, with different chemistry, strange polarization, an aligned trajectory, an inverted jet acceleration without obvious cause, and to top it off, it turns blue. What do we do in the face of such a cluster of anomalies? We could succumb to the temptation to embrace the extraordinary and say it's alien technology. Or we could cling to models and seek a natural cause for each behavior. I believe the answer lies somewhere in between. We must keep an open mind to all possibilities, but demand robust evidence before accepting the most extraordinary. Science advances when we dare to ask questions, even at the risk of ridicule. But it also progresses when we're cautious not to deceive ourselves. I imagine that, if this comet is natural, it will teach us valuable lessons about the diversity of planetary systems. It might point to formation processes that allow giant bodies to be ejected from protoplanetary disks and travel the galaxy. It could prove that comets from other systems contain materials that combine differently, that there are catalogs of interstellar rocks waiting to be discovered. If, however, technology is hidden within, it would be the most monumental discovery in history. It would reveal we're not alone and that other intelligences have explored the galaxy for millions of years. It's an idea that inspires and terrifies. My mind tells me 3I Atlas is natural, but my heart thrills at the possibility it isn't. This duality is part of what makes us human, reason and imagination walking hand in hand. In the weeks following perihelion, the scientific community will continue collecting data. Ground observatories will monitor the comet at dawn and dusk as it moves away from the Sun. Space missions will send their measurements. Analysts will scour spectra for new molecules. And we, following its journey, will keep wondering what it will tell us next. Perhaps the blue hue will fade, and the comet will return to normal tones. Maybe it will persist and become its hallmark. Or perhaps it will unveil another surprise we can't yet imagine. That's science. Every answer opens new questions. The key is to never lose curiosity. I want to conclude this narrative by reminding you that the universe doesn't exist to please us. It owes us no explanations and doesn't conform to our expectations. Our task, as researchers or curious minds, is to seek truth with honesty. 3I Atlas is an enigma, yes, but also an opportunity. It forces us to review what we know, refine our models, innovate with instruments, and debate respectfully. If this story has intrigued you, if it's made you look at the sky with new eyes, I invite you to nurture that curiosity. Share this narrative, support it, and subscribe to our channel to continue joining me on this journey. Because exploring the cosmos is a collective effort, and each of us can contribute with questions, attention, and support. Meanwhile, I'll keep observing, analyzing, and dreaming. Perhaps tomorrow another anomaly will emerge. Perhaps next time, the answer to our questions will be even more astonishing. But we'll always be ready to listen to what the universe has to say.